Here's an example of the small change formula. We've got the range of a projectile as r equals v0 over 9.8. So v0 is the initial velocity, so it's initial velocity squared divided by gravity times the sine of 2 theta. And we're told that the initial velocity is 700 meters per second, and that theta is increased from 10 degrees to 11 degrees, and we're asked to find the change in the range and then the percentage change in the range. So we know that, now we haven't got y's and x here, but the small change rule says that dr d theta is approximately equal to the small change in the range divided by the small change in theta. Okay, now we want to find delta r here. We've got delta theta. It is increased from 10 to 11, and we can find the derivative of this with respect to theta. Now, one thing that when we're doing derivatives is that when we find the derivatives of trigonometric functions, that they should always be in radians. So we need to convert, so our delta theta, which is equal to from 10 to 11, so it'll be 1 degree, and we need to convert that into radians, and to convert degrees to radians you multiply by pi over 180, so that's 1 times pi over 180 equals pi on 180 radians. So with this you can put your calculator into radian mode, and so we've got to find dr d theta. So dr d theta, and we go back to our formula here for r. This is like a constant, that's 700. This is 9.8, so we just got to find the sine of 2 theta and just regard this as a constant at the front. So this is a chain rule problem. So when we find the derivative, this is just a constant, so it'll stay at the front. Now the v0 is 700, so it'll be 700 squared over 9.8. So that's a constant. Now the derivative of sine 2 theta, this is chain rule as I said, so we're going to find the derivative of 2 theta, and that is equal to 2. So we've diffed in, now we diff out. Derivative of sine of an angle is cos, so cos of 2 theta. Okay. The 2 will go into that 9.8 4.9 times. So that'll be 700 squared over 4.9 times the cos of 2 theta. Now it's going to go from 10 degrees to 11 degrees. So 10 degrees in radians will be 10 times pi over 180, which will be pi on 18. So putting it all together, this allows us to say that if we multiply both sides by delta theta, we've got delta theta times dr d theta is equal to the change, approximately equal to delta r. So this is what we're trying to find, the small change, or the change that in the range. So we can quote that now, that delta r is approximately equal to delta theta times dr d theta. So that's approximately equal to delta theta, we said was pi on 180, times now dr d theta will be 700 squared over 4.9, because of, now it's at 10 degrees, it's going from 10 to 11, so theta is equal to 10 degrees, and that's pi on 18. And if we work that out, we get approximately equal to 1640.1. Okay, so that's the small change in range. So we've actually done part A. Now to do part B, and that's meters obviously, to do part B we need to actually find out what the original range was of 10. So when theta equals 10 degrees, which is also equal to pi on 18 radians, the range is equal to, once again, 700 squared over 9.8 times the sine of 2 times pi on 18. And we get a range of 17,101. So make sure your calculator is in radians at this stage, so that's meters. So therefore the percentage increase of R, you always put it over the original, so this is the amount of increase, 1640.1 over the original, 17,101. And to make it into a percentage, we simply multiply by 100, and there's our percentage. So we get 9.6%. Alright, so there's an application of the small change rule. Your first step is to find the change in one entity, in this case it was theta, so it was 1 degree. But bearing in mind that when we do calculus on trig functions, we are assuming that theta is in radians, so it was good to put everything in radians here. That way you can put your calculator straight into radian mode. Find dr d theta, and we can then quote the small change rule and substitute in values to find out what the change in the second variable is. So this is increased by pi over 180 radians, so that would increase by 1640, and then we can work out percentage change.